Hey everybody, this is Larry. This is the weekly contest, bi-weekly, sorry. This is Leetcode Biweekly Contest 161 virtual contest. I don't do these live anymore, unfortunately, for the most part. Honestly, mostly due to cheating, but also due to the fact that Leetcode doesn't care about Python. So here we are. And I went about it a lot, but if you would ask about it, come to the Discord and we'll chat about it. But in any case, I am doing it now, so hopefully this is helpful. This is the screen, the live stream, live virtual video. If you're looking for each individual explanation, well, I have a video for each of those. And that's it. Let's get started. Yeah, hope everyone's having a great weekend. It's so hot here in New York. I mean, actually, it's kind of it's probably very nice unless you happen to be a runner and when you're going for a run and you're just dying. But in any case, all right, let's get started this problem. This contest with paper, pencil, and let's go. Ooh. All right, Q1. I start recording. Okay. Element of primary must go to A. Okay, I mean that seems pretty straightforward. I don't know why they have an empty array thing. I guess that's fair. I mean, it's just annoying, that's all. N can go up to 10 to the 5th, so we just need a surf, right? The other way around. Always forget. What's it? I always have to write this out. Maybe I'll save time. I have template, but it's fine. Actually, this is kind of wrong anyway. I don't need to do even this, but it's fine. Okay, right. Okay. And then now, left is 0 to 0, right is 0 to 0, for I range of n. If prime sub I, prime goes, if it's prime, go to A. So, oh, it's absolute value, whoops. Okay, so then it doesn't matter. I thought it was the other one, not absolute value. But that's fine. And it's 1, 3. Okay, YOLO submit. No silly mistakes. Okay. Whew. I've been making a lot of silly mistakes lately, so I have to hold my breath for a second. All right, let's go. Q2. All by secret. With an island, positive integers. Number of islands, a total. I mean, it's just a regular island problem, right? How do I want to write it? I should just call it go. I don't know why I would calculate because it's just longer. think this is right. This looks a little awkward though. 3, 6. It's way wrong. One is, that's wrong. Nothing at 6 is should be 8. What am I doing wrong? Huh. Oh, because this eliminates. How do I write it? Just do this then. Okay, 2, 6, 8, 5. What's that? 5, 8, 15, and 8. All right, that looks more right. I feel like I haven't did a top-down one in a while. That's why. Hopefully, I didn't make a silly mistake. Okay, I haven't done it. I usually do it. I don't know. Any other way? Maybe with a breadth first search. Maybe I should have done it with a breadth first search. Either way. All right, Q3, and there's a Q4. So far so good. All right, let's go. Async, we have a DAG, 0 to n-1, UV cost. Okay, some nodes online, 0 and online, the total what's the recovery cost? They talk about, oh, the recovery cost is the cost. All intermediate nodes, okay, that's not, okay. You find the total recovery cost is less than k. Depending on the cost of the minimum edge, its score is the minimum edge cost along that path. Return, what the, man, there's so many layers. Return the max path score, the largest minimum edge score. Okay. The recovery cost of all edges, the total recovery cost is the minimum edge cost. Okay. Return the maximum. There's so many minimum, maximum things that are so hard to read. Return the maximum path score amount of other paths. What does it be offline and online? Or how do you turn it online? I don't get it. What is online and offline? Like, it doesn't say anything. It just say that this is online. So do we just ignore nodes that are offline? I'm so confused. If that's the case, then why do we care about offline nodes? Okay. So yeah, so why do we care about offline nodes? This is so confused. I thought recovery means like turn it on. It's just like a totally useless information, which is kind of really weird. But okay, fine. Let's see. 0, 1, 3, 5, 10, 15. So this path is invalid. Okay. Min cost. Okay, total cost is 7. The min edge cost is 3. The maximum of all valid paths. I mean, this sounds like just like a regular BFS problem, but it's just so hard to read for some reason. The min edge cost along this path. What if there are multiple paths? Okay, so if there are multiple paths, what does that mean? Online is really weird, but okay, fine. Okay, so on each node we want to store so of all the edges, this is such a weird one. Okay, so this part is just shortest path, right? But along that shortest path, you also, it's not just shortest path. it is all possible paths, right? But this is a DAG, so okay, so that's the key part, is that this is a DAG, and because this is a DAG, there's a dynamic programming solution maybe. K is pretty big though, so maybe not. And the cost is pretty big, so maybe not. What is K again? K is the total cost cap. I mean, it still feels like it's, I don't know how there cannot, I mean, there could be like a, there be at most 10 to the 5th edges, that's fine. The largest min edge cost. Is this a binary search problem? I mean, I guess it feels intuitive with all the min-max thing, because then now you do a BFS on the min, on the binary search, right? Because now you do a binary search to see whether it is possible. Is that true? It sounds roughly right. Edge is 10 to the 9, so okay. Okay, if this is possible, we have to try bigger. So that means our left is equal to mid. Okay, and then now what's good? Good means that there exists a path largest min edge. Okay, yeah, so that means that amongst all valid paths though, is that right? Because that means that you have to consider all the edges. And this is so hard to read or understand. Because you can't just eliminate the small edges, right? Because they still create valid paths, it's just that it doesn't. I don't get it. I don't know if this is just a gotcha where there's no optimization and it's just always true. Because it's just about getting all valid paths and you can't turn on anything, so I don't get it. Am I just confusing this problem? Are they just kind of confusing you? And is it BFS? Can you do BFS? So minimum. Okay, so I mean, it's almost like we want the shortest path by the minimum path, but we want to make sure that there is a path in which it reaches, right? So how do we assure that? You assure it by, you just construct it backwards? Does it even matter backwards or forwards? I feel like that's a gotcha. Maybe that's not binary search. Well, let's just keep here a bit. Because the minimum doesn't change. Oh wait, this is the largest minimum? So wait, that's not quite right. The largest minimum. What does the largest minimum mean? But I don't think there is a binary search. Largest minimum means that is there a path? Okay, maybe there is. It's just asking, is there a path that goes through? Okay, maybe it is binary search, because then now the formulation is that you don't take any edges smaller than it and still be able to get in. Okay, yeah, that's right. I think I had this idea in my head, but I just, it's, okay, yeah. And I just kind of got confusing along the way. But yeah, okay, fine. Okay, so yeah, okay, what are we doing? It's just so hard to read, I think that's all. Also, this is not a deck. Why does it keep saying it's buffer search? It's clearly dice driven. Okay, right. What is N? Did they tell you N? What is N? N is equal to online.length. Okay, that makes sense actually. I forgot for some reason. Because online.length is useless. I don't know why it is there. It just makes things complicated. Okay, yeah. That's what I forgot. This looked a little awkward. Distance. And then for VC G sub node, if online of V and C is greater than equal to target, then because we just have to find the existence of a path. So okay, yeah, that's why. Okay, and now if this is true, then well, n best sub v is greater than best of node plus c. Okay. Oops, nope. V. It could probably also terminate, but yeah. I guess this is actually return false. We want to write something like if node is equal to n-1 and return true, because there is a path there. Okay, I forgot. It has to be bigger than 9, that's why. 5, 6. Whew, why do I think it's 5? 5 doesn't even make sense. 5 goes 0 to 1, 1 to 3. Oh, I forgot the K thing. Okay. Yeah, okay. So this is not true. This is well, this is the first time. So if D is greater than K, then return false, right? I think technically I want something like this instead, but also n best of no plus c is less than equal to k. Maybe that's a little bit quicker. I always have to remember. Okay. It's my medication timer thing. I always forget though. YOLO. Oh, empty cases. I forgot about the -1 actually altogether. Like I don't return. There's no way for me to return -1. So I was thinking about that actually, but then I just forgot because I got distracted because this problem is so confusing. But yeah, silly mistake. Because we could have done it, but I should have left a note for myself because I was like, oh, remember to think about -1 later. But then I saw that everything is good. I just forgot. Silly mistake. Okay, anyway, Q4, let's go. Given two numbers n k, for any positive integer, define the following sequence. P sub 0 is equal to x. P I plus 1 is pop. Okay, the number 1. Trying to reach the number 1, I guess so, maybe. Is if you get a power of 2. Is the p count depth of x is defined as the smallest integer d such that p of d is equal to 1. For example, p this and this is okay. It has number of integers where the pop is exactly equal to k. Return the number of such. Okay, I mean I have no idea, but it gets into a cycle pretty quickly, and k is equal to 5, which is interesting. I imagine it gets to a cycle, or not even a. Wait, what's the question? Popcorn. Okay, because it just depends on the first number, right? The first number has at most, what is it, 40 or maybe 50 bits. So it's just a number from 1 to 50, and then just counting the number of things that are with that count, right? That should be pretty straightforward in theory. Okay, so then now we just have to do it for 1 to 50, right? So okay, let's just try it real quick. So let's just even go to 60. Why not? Right, and then this is, I guess 0 is not a real thing, so we have to go from 1. F of I is equal to calc I, and then you could do it recursively, but it's fine. It's 60 numbers. What am I doing? Okay, so then while x is greater than 1, x is equal to x dot bit count, I think. Please forget. Return count. And we can print f real quick. And we should be able to match some numbers to it. Oh, whoops. 1 is 0, okay. 2 is 1. 4 is 1. 3 is 2. 5 is 2. 6 is 2. Okay. So we have all this thing. And then now we're just about mapping. What is k again? Oh, exactly equal to k, right? Yeah, then just get about for each number, getting the number of bits. Okay. Then it's just taking about the bits one at a time kind of thing, right? So let's say we have to do. This is in binary. I just start with a small number. That means that I have all the possibilities, right? So then sorry, I had to do it very dumbly because I forget my binary stuff. Right, so then now you have 1, 2, 3 cases, and then technically with a 0, which I guess doesn't really count for this one anyway. But the reason why I have it is for symmetry. So you have 1 zeros, you have 3 1s, you have 3 2s, because of you want to do prefix, and then it just becomes binomial, right? Is that right? 1 threes. And then technically one more for 1,000. So okay, so then we can calculate that, right? Okay, so then you have binomial things. Okay, and then what if you have, okay, so that's the obvious case of what if you have like is it just 1,000 plus 10? Because 1,000, then now again we have the 1,331 distribution, then and then maybe one more for 1,000. No, because then it's 10. It's the possibilities of 10 plus the extra 1, right? So then now this is where the 0 comes in. So it's 1 plus one of the bit count plus f of 10 or something like that in binary. So then it's just everything shifted by that. Okay, that sounds reasonable. And 10 is just 0 and 1 in our case, plus the recursion of 1 plus 1 digit. Is that right? How does this recursion work? Oh, it's the number of things that are, well, in this case it just 0, so that's why it cancels out. Okay, so then maybe what about we take a case like 1111, right? Then it's just 1,000, so it's f of 1,000 or smaller than 1,000, so maybe 3 digits, 111 plus f of 1 plus f of 111, which is the, confusingly maybe, the suffix here, right? And okay, which is fine. F of 111 is equal to, maybe we could redefine this recursively, is equal to f of 100, or technically 11 plus 1 plus f of 11. It's still confusing because of this prefix, but let's just say we have 101. Let's just have this for example. Then now this is going to be 101, f of 101 plus 1 plus, oh no, this is 111 plus f of 101, right, on the count here, and this is defined recursively. And because they only branch once per bit, it should be okay. We just have to be a little bit careful about it, that's all. Anyway, and then 101 is equal to f of 11 plus 1 plus 01, which is just 1. And f of 1 could be 0 and 1. So then now we're Gucci, right? Yeah, okay. Because this is just, it's 2 to the 2, so then it's going to be 1,331. Okay, I mean, I think we got it. How much time do we have? I have an hour, so we should be able to figure it out. It's just, it's not so bad, but it's also not, I feel like it's very easy to make a silly mistake for me. But let's do the binomial. I guess we don't need to do a binomial, we can just cache it. Because it's only up to 50 anyway. Was it n over c, or c over n? Yeah, that's fine. So then now we can, I kind of want this outline, that's why. So then now we have pop count depth is exact. So then now we just count the number of bits after one iteration. So then we just do k minus 1 from that. Okay, fine. Yeah. I mean, you can potentially optimize, but I don't really care enough. Okay, so then now we take the most significant bit, right? Okay, so maybe just redefine a number x. Okay, find the MSB, most significant bit, right? So For I in range from technically max. Yeah, so I got distracted by a dot. Okay, so if this is significant, then we break. And also if this is x, if x is 0, then we just return something like that, say. Otherwise, okay, so this is the most significant bit. So then now we subtract that. To get the, so then now we're breaking into this part, or this into this and this, right? Okay, so then now we have yeah, we get and I will f, but maybe this should be a calculated f. So f of but -1, or maybe just the number of bits is probably enough actually. Yeah, so then now this is going to be 0, 1, 2, 3, so there's 3 bits here, so that's fine, right? So that means that this is going to be a result, and then we also want to calculate this with all the addedness of the prefix. So maybe we have a prefix count or something. So then now we calculate the prefix of the new x without the most significant bit, and then pre plus 1. This is going to be this plus p for the existing number of things. And then we have R2 is equal to this maybe, and then now we just combine them. So for, I don't know, whatever. I'm writing really bad code, but it's fine. Bit pairwise thing, right? I need to figure out how to name these things better. I'm very not happy about this, but I don't want to spend brain cells on it quite yet, and because I feel like my brain track is stretched to the limit. This is technically p, I think, of the prefix that we had, and here we have maybe p times max. I don't know if this is quite right, but we can take a look. And then, is this quite true? Well, it is for every possibility, but it's not times max. Okay, fine, because it has to be yeah, because this is the number of bits, right? So that means that for using it as I is kind of maybe silly, but j is equal to what I call it, I choose j plus p, I want to say, maybe. And then now we have, yeah, f of n, right? Let me just print it before we do anything too funky. Okay, there's a lot of numbers, and this is clearly wrong because there should not be 1 on everything. Where did I do that again? Oh, this thing. Should be 0. Maybe 0 is fine. I don't know. Okay, so 4 you have 1 and 2, which is definitely not right, and 3 and 2 because it should be equal to the n, right? So this is definitely not right, but I suspect it is how I handle the prefix this case. But 4 is 100. So yeah, okay, let's see. XP or 3. Okay, so X, so 400, so it does the 1 but it does 1 plus the suffix, and then oh yeah, that's why it's missing this part. How do I get this right? Maybe, I don't know. That's P maybe. Yeah, this is overcounting then now, right? Because this is 8 and not 7. I don't know if that's quite right either though. So yeah, so this isn't going to be right the way that, but it's something like this, right? Because this part is this part right for 3 is going to be maybe this one is not right actually. Okay, so for 3 we have 2 1s and 1 2, and that's not right. So for the number 3 we have 2 bits. The number 2 we have 2 bits, so we have 2 choose 0. That's one way of doing it, which is true, but we should not count zeros. Okay, I just think I mixed that up. Okay, and then now we can throw away the all of 0 in general, maybe, because that never made sense anyway. So then now this is 4, okay, and this is 6, still not okay. This never felt right. I don't know how. Okay, that's at least we're getting closer without hacking, right? It's just 3, so then it's 4, which is 1 carrying this to 0 because that's no more bits. So that's definitely this case. And when it's this case, it is the prefix. And it's just one case. I want to write all when it's equal to P, but it clearly is not right. Okay, let's see how it is wrong here then. Okay, so 7, maybe that is a good case. I think the easy way to get 7, because 7 is a 1 minus whatever, but it actually is a good debugging case though, because it should not have been. So 1 and 1 is just equal to F or CF of, we have 3 or 2 bits plus kind of 1 plus F of 1 1, right? And then F, this is equal to, let me just write this like this. F of 1 bit plus 1 plus F of 1, and then F of 1 is equal to CF of 0 plus 1 plus F of 0, right? Okay. Well, CF of 2 is going to be, we have 2 bits, so it's going to be 2 1s or 1 2 1, say, right? 0 bits is just going to be 0. I mean, there's nothing here. Do I save that? Or is that right? Let's see, 0 choose 0 plus P. That's a little bit awkward actually. I don't know if this P is up. But it only updates 0, so maybe that's fine. I don't know. We have 1 bit is just 1, right? So 0 1. Technically 1 1, I suppose. Let me actually print this CF. 1 2 1 2 1 1 2 2 is weird, though it's maybe because of this p thing. So actually maybe that's right, that's fine. Okay, let's pretend that's fine because it's 1 plus this, so maybe that's fine because it assumes that there's a prefix of 1. So this is 2 2, okay, and then 1 plus f1, right? And then now f1, this is just 1, but that's on the 0 thing, so it doesn't matter. F of 0, that's the major thing, right? What is f of 0? F of 0, I see. We should not return anything. Where is it? The code. We should not return anything and let the recursion do it, maybe. Yeah, okay. This P doesn't make sense, so maybe we don't do it. And then we just let the recursion. I don't know why I did it top down on this way. Okay, fine. Right. Okay. And then it's 1 plus this thing, kind of, right? So then now it's R2 of this plus 1. And then we can see. Okay, 3 2 is too much, 6 4 is too much, and also you have all these ones. I guess I have to choose where the 1 comes from. Where does it's 1 plus the recursion of things that exist. Is that true? Okay, so I mean this conception makes sense. It's just 1 for everything that exists, but not all the zeros, right? So f11, it doesn't make sense. Or yeah, f11. Maybe something like, yeah, if b is greater than 0, or do we 1 or something like that. Okay, so then now you have 3 and 5, which is still not right. I feel like the idea is right, but I'm mixing something up. If b is 0, if b is greater than 0, right? So that's 100. No, because in this case the 4 goes 0 all the way down. 4. It's not plus 1 on the count. That's why. It's not plus 1 on the count. It's the shift. I think that's where I confused myself. It's going to be b shifted by 1. Because it's 1. Yes, okay. I actually was thinking of that but then I just got confused along the way because it's very easy to. Okay, so then now we want to shift, right? So that means that, let's just say we multiply by 2 in a way. We shift because every count we add 1 to it. Yes, oh, okay. So that means that we want something like 2 is equal to this is kind of an ugly way of writing it, but it's fine even if it's n cubed. And then we move the last element just to keep it the same size. Okay, still no good, but is it closer? I don't know. Oh, that's where the 0 comes into play, because there should be, okay, yeah, because now is where you have this plane, because you have the zeros. The zeros actually matter again. Okay. Whoops. No, maybe too much. Why? If x is equal to 0, then just 1 plus this, right? So we have 1 0. We have 1 0, right? And then it just shifts it to a 2. Right? Why is this wrong? I mean, I don't think conceptually is that hard, but I'm just being dumb. Okay, so if this is 0, R3 is really crazy. Do I manipulate? Oh no, this is 0 because, oh, that's a little bit confusing actually. Let's just write it. Why did I write it like that? Yeah, that looks okay. Okay, so 4. Okay, 0. Okay, so then now we can look at what R2 is. R2. Okay, this is what we actually expected, maybe. And then R. Why not? Why is it so weird? 1 2 1. Then why 1 4? Oh, I left this in here by accident. Whoops. I forgot to remove it. Okay, now we are almost cooking, but not quite. Oh no, yeah. This is 7. This is 4. Now we're cooking, right? So then now we have the distribution. I want to say. Also, let's try a big number. I'm using binary, but well, I'm not using binary. Let's just use a big number. Is that even right? I don't know. So if I don't know, maybe that's a little bit silly. But okay. We could do something easier. In that I know, yeah, because we did. What's it? Calculator. 2 to the. This is 2 to the 10. I know 2 to the 10. I don't need calculator. -1. So then this should be, yeah. Actually, I don't know if this is the. It should be that binomial distribution if I'm right. But calculated in a way, complicated way, or Pascal's triangle, if you will. Because it still kind of merge things together, and it seems like that's right. I googled it because I was too lazy to that should match exactly this function, but it calculated in a different way from the pieces components. So okay, so then now we're done, but we have to kind of convert. So this is after one pass. So to get k -1, so k can be 0. Okay, so if k is 0, then we're a little bit awkward. We have to do k is equal to 0. Okay, have to do k is equal to 0. Have to do k. I'm sorry, I'm repeating it because it's so easy for me to mess up. Okay, what's k equal to 0? K equal to 0 means that the pop count depth is exactly equal to 0. Which is only 1, right? Is that right? Is that only the number? Is that true? I don't know. And then for other cases, then it is just f of n of k -1, maybe something like that. So 1 3. Oh, 2 3. This is 1, this is 3. Why? Well, that's sad. Okay. I mean, okay. 4, what is a 4? 4 only has 1 bit, so 4 takes 1 step. That's right. 1 takes 1 step. 2, what? Oh no, 1 takes 0 step. Maybe I handled 0 incorrectly in this one. Because I think I just assumed that 0 is whatever, but oh no, because of this thing. This I also assume 0. Because then you have 0 has 0 pop count. But does that matter? It does look a little bit weird for sure, because this is no, this is fine as long as you count that 0 is in it. But why am I wrong? 1 and 3. Okay, so 1 it's pop count 0. 2 takes 1 step, as we know. 3 goes to 2, so then 4 goes to 1. after one step, so this is also one step. So it's, and then 0 is just weird, so maybe I handled that weird. I think the number 1, I don't handle the number 1 correctly, that's why. I don't handle the number 1 correctly. Okay. I don't handle the number 1 correctly, which is true. Which is true. Because I assume... Yeah, no. Because 0, I handle 0 as 0. But 1, what do I handle 1 as? So we're close still. But I don't handle 1 correctly. So 2... what do I print here? Hang on. I don't think I used the F, that's why. Oh, okay, I have 2 things named F actually, so that's pretty bad. I think I have to map this. Oh, that's right, I'm being dumb. So this is after 1 step. This is after 1 step. How many counts after 1 step? I'm mixing things up. I'm mixing things up, but we're good, we're good, we're good. I'm just mixing things up, and I keep calling everything F, which is not great. But for F map, I don't know if that's quite right. Okay, so then now, this is the number of digits after 1 step, right? Yeah, let's go see. C sub I, what's C sub I? How much time do I have left? 39 minutes. Is equal to the number of numbers that maps to I after 1 step. But that doesn't mean the number of steps, right? So that means that then now it's for I in range sub max, if C sub I is equal to k minus 1, count we added by, no, this isn't right. This is if F sub I is equal to, then C sub I is, there needs one more layer, that's what I'm forgetting. So then it maps to how many numbers of 1, right? So I is the number. No, maybe this is fine. Maybe this is right. Yeah, something like that. Okay. Yeah, I am confusing naming things a bit. Okay. C is now associated with enclosing. Oh, I keep on naming things. Naming things is so hard. Okay. F of I. Oh, it's FM of I. Naming things is hard. I forgot. Okay. Okay, 4, 3. Okay, not quite what I expected, but that's fine. Why? FM sub I, right? So I, FM sub I. Okay, 0. Okay, K is 1. Is it K plus K minus 1? Because it should not be. So K minus 1 means that it's 0 steps after this. So it should be the number of 1s, right? So that's right. Then why is it not right? Maybe it is, I don't know. Oh yeah, because it's 1 plus 3, right? I mean, there's no way to get 2 from this anyway, but I think the after 1 step is confusing, because after 1 step 1 becomes a 1, but it is not a 1. That's the critical part. But only one number is 1 before the step, right? So maybe we can write this and then CC of 1 divided by 1, CC of 0, maybe. Okay, still not right though. At least the way that I have it. Well, 0, 0 should not, no number should map to 0 after yeah, so maybe I don't even think I did the math from 1. I just kind of, you know. Okay, so this looks kind of right, but honestly, at this point, I feel like I'm hacking a lot and not like, you know, like I'm almost finagling with the data kind of thing. So I'm not super confident about it. But actually, let me double check. This one, I mean, kind of makes sense, but I can double check this one, which is maybe more important. So we have 3, because they all map to 2 after 1 iteration. So I guess it's consistent. Whether it's right, I don't know. All right, YOLO. It's gonna be wrong, but oh, I mean that took way too long. But and there's just so many things to forget. But I'm actually surprised I got it right on the first try. But you know, still a little bit on the slower side for sure. Pretty happy though. Sorry, let me do the work. I mean, it was just a confusing one. Let's do a quick retro of what I think about the problem and contest and so forth. Yeah, I mean, let's see. Q1 was pretty straightforward. I mean, I don't really have much to say about prompt. I did in 2 minutes, right? Pretty straightforward. So Q2 was also straightforward. I had a little bit silly mistakes. It's been a while. Q3, what was my wrong answer again? Oh, the -1. That's a very silly -1 answer. I think this one was also pretty straightforward if I know what it was asking for. It's just a really, I think it's like, of all possible routed paths, I just kind of didn't read it correctly for a while. And this one, honestly, I had most of the idea pretty quickly, I want to say. And of course, I do slow it down for our videos because I'm not doing them for the contest rating anymore, to be frank. So there is a little bit of that. But so I did slow it down, but I probably could have been a little bit faster. I did know about the shift by 1 thing that I should have done here. It was, and I just kind of forgot about it, to be honest. I was like, do you add? I know because I wrote the notation as 1 plus something, and as a result, I just confused myself with the notation. Yeah, it happens, I suppose. Because I knew what I wanted to do, but then I just didn't say it out loud, in the sense of like, once you like if you're able to explain it, then you're like, oh wait, no, that doesn't make sense. But I just didn't say it out loud, not to like prove to the viewers or anything, but because I didn't say it out loud, I just kind of used the notation of 1 plus, as in like, of all the numbers, just shift it to 1 because that's what, you know, there's an extra 1, right? But my notation kind of confused myself along the way, and that's why, you know. And then this is a little bit awkward, but I guess maybe that's fine. Because yeah, and maybe you could have done a count -1 for that reason. Actually, like you this could have been handled in a different way, but it's fine. I don't think there's anything too complicated about this one. And honestly, I don't know why k has to be equal to 5, but maybe there's a better solution that takes advantage that k is equal to 5. Because you see it here. I don't think that it can go that much above 5 anyway, because after 1 iteration, the answer is like, what, 60 or whatever I said? And 60 at most has, like if you do the number of bits on that, it's what? Yeah, so like maybe it can go beyond 5 anyway. So maybe it's actually moot. So maybe yeah, maybe it's a moot point, but a moose point, a cow's opinion. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.